right, boys, just a heads up. We're live on Facebook. We're going to see if we can keep this stream today. Thank you very much. Hold on, Jace. I'm tapping into our Instagram here now. Jace, let me know when you get us. I'm live. You should see us up there.
We're good. Got it.
Alrighty. Boys and girls, a little something different today. We're going to see how things are made. Justin, what's going on?
How's it going, guys? Thanks for tuning in. Sorry we're a little bit late today. It took us a while to get all set up. We are over at the CNC Shop, so we can show you how machines whittle big pieces of aluminum into small pieces. And keep one thing in mind, I don't know everything about all the details on some of these because I don't do any of the programming on them, but we have our resident expert that makes the magic happen around here, Jason. He's behind the camera, and he's going to answer anything that you guys might have. So if you've got technical questions on what these machines are capable of doing or any of the detail stuff, then shoot, Jason's going to answer that for you. In the meantime, we're just going to walk around. It gets kind of noisy out here, so let us know if you can hear or if you can't hear. We'll try and make a change, but let's walk on through a couple of the machines, all right? So first off, everything in a CNC shop starts off with big pieces of material, and then we just start cutting them down into smaller pieces. And these chunks of billet aluminum, in this case, turn into crossover rings. At least in this particular spot, that's what's being converted from billet to crossover. As we get further down the road, we're going to see some extra tools on top of the vertical mill. That's just a tool changer for this particular machine. We'll walk around the front. So this is one vertical machine, or vertical mill that we've got. Not running at the moment. Looks like we're going to be throwing in some more tooling to make more parts. But I think that Jason could probably come around the side and show you guys. If you don't know how these machines work, then we're just going to give you a little bit of an example as we start getting into other machines. Maybe we'll cycle this thing around. Normally, the gauge up in the top of this head has got some tooling in it that's spinning, and there's parts in here that are being machined. We'll even see some of that here in a minute. But Jace, if you've got a second, maybe you could cycle that back and forth.
Yeah, sure. So basic 3-axis vertical mill here. This is what most people will be familiar with. So I'll start with the Z-axis. It goes up and down like that. I want to be careful not to go too far with that. X-axis will be this way. There you go. And Y-axis, that'll come towards us and away from us this way. So a basic 3-axis vertical mill, X, Y, Z.
So we'll come back to some more milling stuff here in a minute. Some more...
And we got a question here from Jake Barner, I think it says. Do you recycle your scrap aluminum back into bricks yourself, or do you outsource recycling? We're kind of a small shop here, so we outsource that, and we end up recycling tons of aluminum in particular.
Actually, that's a pretty good stat. That would be when we're running, right now everything's kind of cleaned out, but when we're running X3 racks, for instance, and we're removing a lot of material off of a billet chunk, we end up going through about how many pallets of recycled material? About 6 a week?
Well, this bin behind you here, this blue hopper here, holds 500 pounds of aluminum turnings out of this particular milling machine. We'll fill that up in 8 hours of running. So 500 pounds of small chips of aluminum in 8 hours.
500 pounds in 8 hours, and then that means in 1 week we're going to throw about 3,000 pounds on a trailer and take it to recycling every week when we're running X3 racks.
It's like $1,000.
$1,000 in chips. Seems like a lot of effort for the 1,000, but we always take what we can get. Over this direction are some of the lathes. And this is Tyler. He's in charge of running some of the machines over here. How's it going, buddy?
It's going great. How you guys doing?
So he's going to start a process on a new part right this second. So if you take a look inside the machine, we'll hit go and you can watch that thing machine out. I believe we're making high miss spacers, right, Tyler?
No, it's
just a radius rod spacer or something, I think.
Yep. So we're making radius rod spacers right this second. You guys watch that go through its process. Tyler, how many minutes is this part?
Just about 2 minutes, minute and a half.
All right. So we'll watch this for about 2 minutes, you guys, and we'll watch this thing spit out in about another minute.
And this is a 3-axis lathe. It's got the basic 2 axes of a lathe, which are Z and X, and then its 3rd axis is a C axis, which makes the spindle become a rotary axis.
All right, looks like we dropped a part in the bin. Chase, why don't you back up so we can grab that, all
It's
right?
gonna come out in just a moment.
I thought I heard it.
And the parts catcher went up, and now it spit the part out now.
Here it is, guys.
All right, so that's a stainless steel spacer for any of the rod ends that we have. We have a lot of rod ends and a lot of components, from sway bar links to radius rods, a ton of other things. So we go through a lot of stainless steel spacers per week.
We got a question from
Question, Jace?
Jack Barnier, I think. He asks, is billet just the finish on aluminum? And billet just means it starts out as a solid chunk of aluminum. That's what the word billet means.
Hopefully we answer your question on that, buddy. Back to the spacers. I think we're running about 1,400 spacers in a 24-hour period. Is that about right?
1,200 in a day.
1,200 spacers per day we are currently making, and that is barely keeping up with some of the production on our components. So as you can tell, we're a little bit cramped when it comes to our CNC capacity, and that's why we're actually moving all of the machines into the new race shop. So we're kind of giving you a heads up of what we're doing right now as we're currently moving machines to the new shop. When we get to that shop, we're going to come back and give you another tour when everything is completely set up. Here's the other lathe, and it's going to start its process, and it is making radius rod ends. So this is currently a hard anodized radius rod, and the machine is doing the final process to knock the shape into the end.
So you can hear the sound of the interrupted cut of the bit going over the hex material. Kind of hard to see in there with all the coolant spraying around, but if we turn that off, bad things happen.
We got to keep our cool around here.
That's right.
Hey, Jason, got any other good questions while we're waiting for this part to spin up?
Nobody just yet.
This is incredible, man. Talk about making parts with futuristic machines. Hey, how much was it, speaking of futuristic machines, how much does each one of these machines cost, Jason?
These all can vary, used from around $50,000 up to $150,000, and brand new they're about $250,000.
Jeez Louise. It's a pretty nice Ferrari.
Not sure if you guys heard that on the Instagram feed, but the question was, what do these machines cost? Well, used between $50,000 and $150,000, and new $200,000, $250,000. How much more time do we have on this process, Tyler?
It just finished up, Justin.
Okay, cool.
Clean it up real quick.
Diversified Fab says, what's up, Jason? Hello. And hashtag no chase.
Hashtag no chase. Thank you very much, Diversified, for checking in. All right, you guys can see the end of that radius rod. That last machine process is what was just done to give this cool shape on the end. And we end up doing both ends of this radius rod, and it's ready to come back to the shop and get completely assembled with rod ends and go out to you guys. Thanks, Tyler. We're going to move over to the next machine.
Sounds good, Justin.
So over this way, we've got another mill. This one's quite a bit bigger than that first mill. If you guys know anything about this, then well,
We have
I don't have to tell you.
a quick question. Somebody asked, Be Right 412 asked if we started with all this equipment in 2013, or this has been from growth. has it been for growth?
In 2013, there were 2 machines. So
Yeah, that's right.
everything that you see around here after 2 machines has been due to growth.
We got another repeat offender on the questions here. Asks, does your machine shop work around the clock or just regular business hours?
Right now, depending on the production, we go for a swing shift or a single shift.
Depends.
It just depends on what we need for production. But the biggest thing that kind of dictates what we can do is the power. We're pretty much out of power in these units, and that's why the machines are being moved over to the new race building. When we move over there, then we'll only have to run 8 or 10 hour shift as opposed to running 2 shifts here.
And another question, Wiley Coyote Caller asks, do you guys anodize your aluminum in-house or do we outsource it? Unfortunately, I'll take this one. Unfortunately, we have to outsource it.
Yeah.
Hate outsourcing anything, but just for a lot of EPA laws and stuff like that, getting anodized in-house here would be pretty difficult. But if you know anybody, let us know, please.
Yes, I will actually put more on top of that one and tell you that anodize is the one thing that we have probably the most gray hair from having to deal with. It always screws with our production. We're a lot quicker than the anodizers are, so that always holds us up. So over here we've got Scott, and Scott's working on the tombstone section of the horizontal mill.
Yep.
And what he's doing is changing parts on the tombstone. Well, this tombstone is 4-sided. We were only using 2 sides of it right now with vices on both sides. We can use all 4 sides, and the machine is actually running parts as we speak while these parts are being changed on the other side. So this one never stops running. Over here, Chase, I'll show you some of the stuff that's coming out of this right now. So this is a center link for an X3 billet race rack. That actually starts out of a solid chunk of chromoly. And one of the first processes in this machine is to knock out the basic shape. And then we'll change this part again, maybe another direction or sideways, and we'll finish off all of the other machining processes, including the teeth on the back that allow you to set or limit the bump steer in the center link by raising and lowering the center link. Let's go around the front of the machine and kind of show you the business end. Let's go this way, Chase. So inside here, instead of having the live head coming down from the top like the other machine,
Horizontal.
this horizontal mill comes in from the right side facing the left. That allows us to work a lot more angles on the tombstone and a lot more parts. So let's see if we can actually move this thing around. If we're gonna look at tools, I forget.
Yeah, let's with the door open, it doesn't let you get away with much. So let me see real quick if it will.
It's probably a good thing.
Yeah, no, this would chew you up pretty fast and spit you out. So the XYZ we were talking about on the vertical mill, it's exactly the same here except it's horizontal. So your Z-axis is moving towards the tool in there right now. So there's your Z-axis. On this one, we now have a B-axis. So now that tombstone rotates on the 4th axis in this machine, which is referred to as the B. So you get X, Y, Z, just like over there, with the addition of a B-axis on this. Let's close the door, we'll change some tools.
Yeah, let's do that.
So, all these machines, the lathes, the milling machines, in order to be productive, have to change tools and change them really fast, many thousands of times each day. So we'll show you some of that right now. I gotta get on this side of you, Chase.
So guys, what we're going to do next is show you a couple of tool changes, which in this machine are pretty much lightning fast. Tools come in from the back of the machine, and we'll show you where those are held as well. That's it. One tool changed. About 1/4 of a second on a tool change. Want to show the back?
Yeah. He was just getting ready to fit another one in there. There we go. So yeah, let's go around the back, take a look.
All right, let's go around the back of the machine, Chase. We'll show you where all the tools are held and watching those actually move around. Take a look over that way. What you're looking at is the back of the machine. And this is where all the tools are held for all of the different jobs and processes that this machine goes through. You can see that tool changing happens fast, and it kind of rotates this chain link assembly as needed to grab the next tool. Very cool, huh?
Old trick.
All right, guys, what we're gonna do now, we're gonna walk over to the next building and kind of show you a couple other machines that we've got over there. And
We got a question.
Oh, another question.
BWB Dub, how often do you have to replace the tooling? That's a really good question,
Yeah.
actually, and it's a big financial aspect of machining stuff as well. With aluminum, not so much. The carbide tools, for example, last a long time with aluminum. When we start getting into 4130, 4140, chromoly, or other harder stuff, stainless steel, then that tooling is changed on a scheduled basis, like per amount of, or how much time it's cutting, based on how much time it's cutting, or how many parts, specific parts we make. For example, like a drill, we might say we allow a drill to drill 1,000 holes, and then we'll replace that drill. In different material, it may only be able to drill 200 holes. It just depends.